I was that night. I got diagnosed at 8 a.m. and I had the surgery at 7 p.m. I was that night. So there's my...
And they said 48 hours.
48 hours I'd die.
So we might actually have all the source material to find the cure for cancer. We need someone like you to like put it all together.
If you have been diagnosed with cancer, this will give you a better outlook. If you don't have cancer, this will decrease your chances of getting it. This should prove everyone wrong that cancer is a metabolic disease and it's not a nucleic disease.
What was going through your head when you were first diagnosed with brain tumor?
Yeah, so I'll tell you the story.
Yeah.
That's my theory and the theory I want to present to people. If you've been diagnosed with a tumor, it's not out of your hands. Have faith, but also know that you can take steps to improve your health.
Which is, if you could simplify that to the audience in like a sentence or two. Just simplify and summarize the cause for cancer from that.
I get the CT scan and the doctor comes out. He's like, you're not walking anymore. He put me straight in a stretcher and I'm ambulanced to the hospital. And they told me, and at that point I didn't find the answer. What gave me relief in those 4 hours was that this is pure survival mode. I was like, all right, it happened to me. This is not me trying to be a hero. This is me being completely honest.
Mm-hmm.
I don't think I told anyone this. This is what I thought to myself. If this had happened to my mom, I would have preferred it happen to me than my mom. That's not me being a hero, that's me being selfish. That would have been harder for me to deal with. If it happened to my sister, to my brother, it would have been worse. So actually the best case scenario is that if it had to happen to someone, it happened to me because I can take it. And I did. Like I'm here. The main thesis I'm trying to say is that
Welcome back to the Thomas Botea Podcast, everybody. On today's episode, I have a good friend, Ishaan Banwait, on. Pleasure to have you on.
Thank you.
Yeah. What if everything you thought you knew about cancer was wrong? Today, I'm sitting down with Ishaan Banwait, an MMA and jiu-jitsu fighter who's taken punches in the cage and hits to the brain, literally. After being diagnosed with the brain tumor, he didn't just survive. He dove into the science himself, uncovering what mainstream medicine might be missing. Today, he joins me to talk about the fight for truth in the cage, in the body, and in the mind.
Mm-hmm.
But Ishaan isn't just a fighter or a researcher. He's also a thinker. He writes articles on Medium, which you can find down below. And you're good if I plug you, right?
Absolutely, yeah.
Yeah, his articles challenge not just the cancer industry, but our ideas about meaning, discipline, suffering, and how we define health. This conversation is about more than medicine or martial arts. It's about facing the hardest truths and choosing to live anyway. In this episode, if you stick around, we'll have a few sections. We'll start with personal journey resilience. We'll go on to fighting and discipline. And then we'll go on to cancer research and medical reform, which he's looked at. And then we'll go more into his storytelling. And then we'll finish off with legacy and meaning. So yeah, pleasure to have you on. Any opening thoughts or remarks before we get started?
Yeah, never been on a podcast before, but excited for this.
Yeah? Yeah, pleasure to have you on because I know if we could just, let's start from the beginning.
Mm-hmm.
Like, what was going through your head when you were first diagnosed with a brain tumor?
Yeah, so I'll tell you the story.
Yeah.
Most of the time when people have brain tumors, they have a lot of symptoms. So you have like seizures or dizziness. My problem was because I was training so hard. At this point, I was wrestling at a gym in Waterloo and I was also boxing, kickboxing. I just always attributed all my symptoms to like symptoms of fighting or like sparring.
Oh, you
and doctors did that too. So like my major symptoms at that point were this really tense headache I would get in the back of my head, which is fair enough where the tumor ended up being.
Wow.
And I would also get dizzy. Like there was a point where I was at jiu-jitsu. And you know how we went to jiu-jitsu together for a little bit. That's how we know each other. Mm-hmm. But do you know how you do the front rolls and the back rolls down and back the mat?
Yeah.
I would get so dizzy, man. And I asked our coach once, like, is that supposed to go away at a certain point? Because like I'm feeling really bad. And he was like, oh yeah, I mean, everyone's dizzy, it just kind of goes away. That never went away. And so that should have been my first sign. It got to a point where like when I would wrestle and I'd roll, it would take me like 10 seconds to calm down. But I never went to the hospital or anything like that. I talked to my family doctor, and they were always just like, yeah, concussion. They're like, did you get hit in the last 2 weeks? I'm like, yeah, quite a bit. And then they're like, okay, well,
Yeah.
that's what it is. It's like whiplash concussion.
Yeah.
So I'll paint the story for you. Where I was I was working full time in Mississauga, my first time in a office corporate environment. Was making the most money I ever made, was busy all day, was at home for the summer, was enrolled in university, great job. But that was truthfully the worst time in my life. So for me, what a day-to-day routine looked like was I'd wake up in the morning. I could not keep any food down, so I'd throw up straight away in the morning. And I would continue throwing up until I had nothing left. Then when it was time to leave for work, I'd put on my work shirt, I'd take a shower, put on my work shirt, drive to work in traffic.
So you just casually threw up before going to work?
Yeah, I mean, like, I'm a
Wow.
tough guy. I'm not going to tell anyone,
Yeah.
right? Like, my
Yeah.
dad knew, my
Yeah.
best friend knew. That's pretty much it.
Yeah.
Yeah, so I'd go to work, and sometimes at work I'd have to throw up, like, in the middle of the day. I could not eat anything. I didn't tell anyone. I'd just go to the washroom. I'd be throwing up, like, the head pain.
Whoa.
Again, like, I didn't really think much of it. The day that really struck me as important, significant, was I was driving to work one day on the highway, going exactly the speed limit, and I was driving, and for like 1 second, I just lost my vision. So I just had this intense, like, vertigo is now what I know to call it, but everything just spun, and I couldn't see. So in my mind, I was thinking, I'm already going straight, the road keeps going straight, all I have to do is keep my hands on the wheel, and I can't mess up. So that's what I did for like a second or two. And that night when I got home, I told my grandma what happened. And she truthfully saved my life. She was like, you're going to the ER tomorrow morning. Like, I don't care. You're going to the ER. So that night I still kickbox barred. I was talking to you about this. The next morning, 5 a.m., I go to the ER. And like, again, same spiel. The doctor's like, oh, well, it's whiplash. You've been hit. Like, you're totally fine. But because it's only 8 a.m., we can get you in for the CT machine. So I'm there, I'm chilling. I get the CT scan, and the doctor comes out. He's like, you're not walking anymore. He put me straight in a stretcher, and I'm ambulanced to the hospital. And they told me what was going on kind of on the way. So that's the story of how I found out.
And you don't think it was, you didn't receive it through fighting? You don't know how you got it?
No, I mean, for sure not through fighting. How I got it, there is a component of cancer that is, I don't want to say random, but like there is a component of it that is stress, chance.
Mm-hmm.
What I'm saying about stress is that through my research, I found out that stress is actually the number one indicator of cancer. It's not mutations in the body, it's stress particularly to your metabolic system. So stressing the mitochondria through like hyperglycemia, eating a lot of sugar, fast digesting sugar, spiking your insulin. When you chronically put those mitochondria under stress, that's when you get to cancer. And we can talk about that. For me, in my case, I always ate healthy. So I think it was just more mental stress and always working hard at the gym, not eating enough food. That puts you under stress as well, right?
So it was stress. It wasn't related to the fighting.
Absolutely not. No, there's no way. Yeah.
Wow. Wow, it's crazy how that could just pop up, and and you were telling me this, like, it could just appear in anyone.
Yeah, I mean, so as part of my cancer research, I kind of put together a little presentation, which we'll go over.
Yeah.
And one of the craziest stats in that is that 1 in 5 of us will die of cancer. And this is in a textbook published in 2019 that I used first year at university because I'm a biology student. So this is like in the textbook. If you go on like the US National Gov website for cancer, that same stat is there. 1 in 5 of us.
That's 20%, no?
That's ridiculous.
Wow.
Is what it is.
You were saying, like, you're a tough guy. You couldn't tell people that you were, vomiting at work or even beforehand. Mm-hmm. So what I want to ask you, and then we're going to go into the fighting discipline. But before that, like, was there a moment where you ever felt like giving up? And if so, what pulled you back? Like, why did why did you show, that mask of like confidence to say that? Yeah,
I mean, it wasn't a mask. That was how I truly felt. Good question, though. There was only about 4 hours in the entire process where I felt truthfully like lost and just kind of upset about everything. And it was when I first woke up out of the surgery, I was really, I was not conscious. Like I was very delirious. I was not good.
Is everything moving?
Bro, I was hallucinating things. I was speaking gibberish. Like when you mess with the brain, it gets really bad. So I was not able to be talked to sensibly for like a couple days.
Wow.
When I finally became present in my own mind, I mean, obviously, the first thing is like, why me? Like, why did this happen to me?
Out of all people, yeah.
And my whole thing is like, I mean, you can see this in my Medium, my optimism article.
Mhm.
I'm cool with anything as long as I understand how I can flip it into a win.
Yeah, so you're okay with it if it flips it into a win.
Yeah, like champions don't wait for success; they create it under their own conditions. You know, so that was what I was struggling with for about 4 hours, and I knew it wasn't anything to do with my health that I had done. So I was like, hey, why did God give this to me?
Yeah.
Right. And at that point, I didn't find the answer. What gave me relief in those 4 hours was that this is pure survival mode. I was like, all right, it happened to me. This is not me trying to be a hero. This is me being completely honest.
Mm-hmm.
I don't think I told anyone this. This is what I thought to myself. If this had happened to my mom, I would have preferred it happen to me than my mom. That's not me being a hero, that's me being selfish. That would have been harder for me to deal with. If it happened to my sister, to my brother, it would have been worse. So actually the best case scenario is that if it had to happen to someone, it happened to me because I can take it. And I did. Like I'm here. Right? So
wow.
That was my thought process.
That's really sound thinking. I applaud you for that. That's
Thank you, man.
That's crazy. You're casually like, yeah, just give it to me.
Yeah, I mean, I haven't had a problem after that. I've been very good, and I've been treated very well by universe, God, however you want to interpret that.
Yeah,
I've been good.
Did that affect your faith in any way?
For sure. Mm-hmm. Yes, it did. Like I've always believed in God, but kind of like I'm a scientist, right? So I don't believe there's some man in the sky watching me, but I do believe that the way that humans interpret God is a way for us to teach ourselves lesson and keep ourselves tamed.
For sure.
Right? It's a way to understand how to live in the world.
For sure.
Right? Morals, things like that. You always imagine someone judging you so that you act in your best interest all the time. So for me, it gave me a little bit of peace in those moments, being like, all right, he has a plan for me. I'm not supposed to die. I've never, like, bro, I'll tell you things. Like, I truly believe that I'm favored by God. I know that's very egotistical to say or whatever, arrogant. I was really struggling with my coursework. I'm in 2 classes right now, just part-time as well as working. And I was really struggling with keeping up with the course load. There's a point, it was May 26th, 3 weeks into the course.
You know the exact day, wow.
Yeah, you can drop the course and get a full refund, and it doesn't show up in your transcript. So a lot of people will, in university, try the course up until this date, and if it's too hard or they're too overwhelmed or they don't want to take it, they'll drop before that date. So approaching this date, I was really struggling. I get like, not so much anymore, but back then, a couple months, I get like flashes of pain, headaches. My vision would go blurry if I overexert myself.
Before or
if I
after
read too
you went
much.
to the ER?
This is all from the surgery.
Oh, after. Okay.
This is when I got home. This is in May.
Okay.
Like this past May. And
oh, it's recent.
Very recent, bro. Like this is something I'm dealing with now, is like energy. But I decided, no, like I'm not going to quit. I don't do that. There's 2 ways out of this. I know that dropping the classes will fix my problem, the surface problem, which is that like I have this pain, but it's not fixing.
It's not long term.
It's a short-term fix.
Yeah.
And it, like, what kind of person does it make me into? It makes me into a quitter, essentially.
Exactly.
Right?
And then down the line, what are you going to do? Just quit the next thing?
Bro, exactly.
Yeah.
So like my whole thing was, I know there's a way through it if I keep with the classes. I'm going to put, this is where the faith comes in. I'm putting my faith in myself and in God that I can be fine. And I did that, bro, the very next day, like, or actually 2 days later. I used to have this thing, you know when you're at the gym and you superset, like you may superset like tricep pushdowns and bicep curls.
Yeah, you change.
It's not a great superset, but it's on the same machine.
Yeah.
I had this thing in university I built where I would just superset life. So I didn't have time to work out, right? So what I do is I would like steady in my computer, and then on the chair I do like decline push-ups, do 50, back to steadying, and I go back and forth for like 8 hours straight. Obviously I could not do that in my current state, and I haven't been able to, but I've been trying. 2 days after I kept the courses, I was able to do that.
Wow.
So like that's what I'm saying is like, bro, if you work hard, you get smiled upon, you know?
And if you like, you said you had the faith.
Yeah.
Because quitting in itself shows that you don't have faith, right?
Yeah.
So if you did that, you wouldn't have been able to like recover as you've done today.
Yeah, but like also I'm a realist. You can't just say you're putting faith in something and then like pray. Like you can't. I don't like leaving myself to.
You still need to work towards
Life
it.
doesn't happen to me. Like I gotta happen to things. So it's you put faith in things, but you use that faith to fuel your actions. Like you have to take action towards things.
Yeah.
Right.
You know what? Let's just go straight into the presentation.
Yeah, absolutely. Yeah.
Because that's what the viewers are here for. So let's make it good for them. So let's just go through that. You know, you've put this together because it happened to you, so you're trying to research upon it, right? That's what I'm assuming kickstarted this?
Well, dude, I've always had the idea in my head, which I didn't tell many people, but I guess I'm telling everyone now, that I would cure cancer. So like my close friends knew that, my family knew that, but like obviously it's not something I was saying to everyone because people see you as arrogant.
Yeah.
I always thought I would cure cancer, to the point that in high school, when my friends and I came across like a good amount of money through something we were doing, they all donated a portion to cancer research.
Wow.
And I refused to because I was like, I'll do it myself. I'd rather invest in myself. So I've always had this idea that I'm going to cure cancer. Or not always, but like since the end of high school. And I went to university. I'm like halfway through my undergraduate degree there. And obviously this became a lot personal for me when I actually got diagnosed with a brain tumor.
That's so crazy to think you were thinking about this before you knew you had the tumor.
Bro, it's God's plan.
Yeah.
You know what I mean?
Yeah.
So we'll put this up on the screen, but like I'll just show you, Thomas.
This is slide one.
That's my actual diagnosis.
Yeah.
So you can see it's down here, and it was about like 6-7 centimeters in volume.
Yeah, 6 or 7. Yeah.
Bro, if you know anything about tumors, that's huge. So I was given 48 hours to live. Like they thought I was gonna die. You know what I mean? Like most of the time when you're diagnosed with the tumor, it's like, oh, we're sorry to tell you, you have a tumor. We're gonna set you up with an oncologist.
Yeah.
We're gonna talk about your plan. Choose if you want, radiation or surgery, and then maybe we'll book you for a couple months. I was that night. I got diagnosed at 8 a.m. and I had the surgery at 7 p.m. I was that night. So there's my.
And they said 48 hours.
48 hours, I die.
Wow.
I don't believe that because again, I'm a tough guy, but like that's what they told me.
Yeah.
I could have been like a week.
Yeah.
I could have been good.
Yeah.
So what the doctors told me was that.
So this is slide 2.
This is slide 2. But
yeah.
It's all right. This is more what we talked about.
Yeah.
1 in 5 people will get cancer.
Yeah.
I guess we talked about that off screen, but this is the craziest stat. This is from my first year cell bio textbook. 1 in 5 of us will die of cancer in our lifetime. And Thomas, the graph I've put here is the prevalence of cancer across people. I think it's over the age of 12.
It's not changing.
12. It's not changing. So cancer is prevalent. And then also people are still dying from it. So like that's ridiculous to me, given the fact that this stat here, $24.5 billion US spent on cancer research.
Where's that going?
Well, I mean, it's probably going somewhere, like a large portion of it, but it's not being spent in the right way. So I realized something was fundamentally wrong. When I was in the hospital, again, I'm not like a victim to anything. I thought, what can I do about this? I need to be able to take my fate into my own hands. And the doctors basically told me there's nothing you can do. Like it's random, it's genetic mutations. And so that brings us to the somatic mutation theory, which I'll pull up here. This is the somatic mutation
what is this? Yeah.
Dogma. So this is what's taught in schools. This is what, if you ask a doctor and they're uninitiated, this is what they'll tell you, is that cancer arises from random mutations. So maybe carcinogens cause them, maybe the sun causes them, whatever it is, you're smoking. You get random mutations, but it's kind of just like, it can happen to anyone. There's nothing you can really do about it. I wasn't cool with that. And once I looked at this research and I saw that, okay, what they're thinking based on this presumption is not working, I realized there was a fundamental flaw. So this is on the National Cancer website, like US Gov. It's a website. And the very first word, like sentence is cancer is a genetic disease caused by mutations. So like this is at the highest levels, institutions, this dogma is believed. Here, this is from that same textbook. So again, cancer is like a set of mutations caused just randomly, and there's nothing you can really do about it. These are screenshots from my actual first year course. The way that they present cancer to you, and I'll speak about this very briefly, is the analogy of a car, right? You either have brake failure or you have a stuck accelerator. So a stuck accelerator means that you have some proliferative genes that would translate into proteins that cause proliferation, differentiation, growth. If those have a mutation in them that causes unbridled growth, That's cancer. That's a stuck accelerator. The second way is brake failure. So we have tumor suppressor genes, right? P53 is like the biggest one. And if there's a mutation in these, they can't halt the unbridled growth anymore. Brake failure, you get cancer. So that's the two ways they teach it to you. And now I'm going to break it all down. So mutations are not the cause of cancer. I have two main points here. So flipping to the next slide. What I did was, so I looked into some research articles that were actually sequencing mutations in tumor cells. So this one here, they looked at 20,000 protein coding genes. So these are exons, so they actually express proteins. And only 3.3% of the genes had any somatic mutations. So if you look at this table here, right, these are all the top oncogenes or cancer-associated genes. And here that I've circled in red is the fraction of tumors that have that mutation. And you can see even the most common driver mutations appear in like 35-40% of samples.
Mm-hmm.
So it's really weird that they say mutations would cause cancer, and these are the genes that they would cause cancer if these were mutated, but like only 35% of them max are actually, or tumors have these mutations.
So they're only 35% correct.
Right. And it's like, yo, would you put $1 million on something that only had a 35% chance of hitting?
Well, the U.S. put $21 billion onto that.
Good point. It's a good point. And I mean, like, here's another study. They looked at 518 genes and 210 diverse cancers. So like that last slide, they were just looking at glioblastomas, right? Which is like the worst type of brain tumor. Actually, while I was doing this research, in like the 1 year I was doing this research, someone I know was diagnosed with and died of a glioblastoma. So like this is very...
What's that?
So someone I know was diagnosed with a glioblastoma, brain tumor, and they died of it while I was still writing this research. So there is a need for this.
Rest in peace. I'm sorry to hear that.
There's a need for this, right?
So while you had it, someone also died from it?
I don't have a glioblastoma. Mine's a different type. It's less aggressive. But a lot of this research is on glioblastomas because they're the most aggressive.
Was this person related to you?
No.
Okay.
And I don't want to talk about it too much, but it's just someone I was
thinking maybe it could have been genetic if it was.
Again, genetics play a very small role, but it's not actually a genetic component. The main thesis I'm trying to say is that the genetic instability that we see in tumors are not the cause of cancer. They're a downstream effect of the actual cause, which I'll get to.
That's powerful.
It's mitochondrial dysfunction.
Mm-hmm.
So this is the mitochondrial metabolic theory of cancer. And I'll talk about how you can then cure it based on that presumption. So back to the mutations, these guys looked at 210 diverse cancers, not just glioblastomas. And 73 out of 210 had no mutations in those coding genes. There's a whole bunch more stats here.
So mutation means what for those who are watching?
Yeah, for sure. So you have DNA, right? And DNA are the instructions that each cell uses in your body to express proteins. Mm-hmm. So what happens is you have this like library almost. That's your DNA. And based on how you're feeling, like with your environment and how stressed you are, things like that, there's a theory, not theory, there's a concept called epigenetics. So some of those genetics, or some of those DNA bases get expressed into RNA. Once they're RNA, then they go into proteins. Okay? So that's
so when they're duplicated, kind of.
Yeah, like you get a copy of them, right? Because it's like, if you had a library, right, and you wanted to lend a book to someone, you don't want to give them from your actual library if that's something you want to use. Because you may have to give that book, copy of that book, to like 10 different people. So the original copy you don't want to change. It's actually key. The original copy you don't want to change. Mm-hmm. You only want to make a copy and then express that copy.
Okay.
So mutations are a change, right? Mm-hmm. So they're changing the library. So when you have defective genes, you get these mutations and they cause the gene to be expressed in a way that's not expected, right? And when that's in cancer genes, oncogenes, then you have cancer. That's what they tell you. So
oncogenes is this like a synonym for cancer genes?
Yeah, so they're called proto-oncogenes when they're healthy. Mm-hmm. So when they're dormant, we both have oncogenes. Everyone has proto-oncogenes.
Wow.
These are just regular genes that, when they're mutated, become oncogenes and drive cancer.
Oh, okay.
Yeah, so there's nothing wrong with them.
So how do they get mutated?
So they'll tell you it's from carcinogens and the sun.
That's kind of like, if you think about it, that's saying you get cancer from carcinogens is kind of like a circular definition, no?
It's
saying you get cancer from cells that have cancer.
Well, no, carcinogens aren't cells that have cancer.
Yeah.
They're environmental toxins
Yeah.
that cause you to have your DNA damaged. So, for example,
Yeah.
smoking, incinerating things, or like they'll tell you the sun's been fine for like billions of years, but now suddenly it's causing cancer. So they'll tell you cancer causes mutations as well, which it does, but it doesn't cause cancer.
So you don't think the sun is actually like a root cause of it?
It's not. So I'll skip ahead a couple slides.
Like scientifically, it's not?
Scientifically. So first problem that we went over was that there's a lack of mutations in cancer cells.
Yeah.
What I'm going to show you now is that there are mutations in healthy cells.
Uh-huh.
So what this study did, and I've put all the citations here if you want to go through them in my Medium article, they looked at RNA sequencing data, so that those copies, the RNA, from 6,700 samples across 29 normal human tissues. So these are people who don't have cancer. And they found mutations in 95% of those people. So you're saying mutations cause cancer. These guys have, like 95% of people already have the mutations. 33% of people, so that they sequenced, had at least one mutation in one of those driver genes.
Wow.
Right? So like already that's pulling apart the presumption that mutations would cause cancer.
Yeah, it pulls it apart.
I want to go to this one because you talked about the sun causing cancer. So these guys sequenced epithelium cells. So epithelial cells in your esophagus. So like in the tract of your esophagus, the inside lining, that's your epithelium. Mm-hmm. So they looked at epithelial cells from 9 deceased organ transplant donors, ranging from 20 to 75, no prior history of like smoking or any chronic issues in their throats, and they found 14 genes under positive selection. Okay, so these 14 genes they found to be mutated, to be upregulated. They were significant, these 14 genes. 11 of those 14 were known drivers of esophageal cancer.
Wow.
So you want to talk about statistics? 11 out of 14 of the genes that are known to cause cancer in that spot were in healthy people, right? And they go on to say...
So it's got to be a combination of different factors. It can't just be those genes.
Yes, it's a combinatorial effect, right? It's a couple different things. Like all complex things in life, it's very hard to pinpoint it on one thing. But the thing with cancer is that, okay, mutations are a part of it, but there's a very big part missing. And that's evident by the fact that all the billions we're pouring into research isn't really actually creating a positive functional outcome. Mm-hmm. So I'm glad you asked about the sun. I don't wear sunscreen. If you check my suntan,
yeah,
I don't wear sunscreen.
Why?
Well, I mean, I don't think the sun's bad for you. Like if you're working all day in the sun, obviously. But like this study, it's not in the presentation, but if you read the article, they found more mutations in sun-exposed skin, for sure. So like sun-caused mutations, but they found more cancer in the other group that was not sun-exposed.
But I'll throw the photo up here so that the viewers can see. But have you seen the photo of that one truck driver who's 60, and after I think 30 years of truck driving, on one side of his face, mm-hmm. that was where the window was, and the sun would hit him all the time.
Yeah,
and you could see half of his face was drooping and the other half looked normal.
Yeah, Two-Face, bro.
Two-Face?
You know, from Batman?
Yeah.
I haven't seen that picture, but like sun definitely damages you.
Yeah.
It just doesn't cause cancer. That's my point. It causes mutations.
Oh, okay.
It'll burn you. If you're out there for a long time, you'll get red. Your skin will peel. Like that's all real. Yeah. But like what I'm saying is that it doesn't positively correlate to cancer every time.
So it still affects
a conflation.
You. It still affects you, but it's not.
It's still bad for you.
They confuse it. It's not really a cancer
causing. They conflate it. Exactly. That's exactly what it is.
That's interesting. But a lot of people probably don't know that.
I mean, it's not something I know a lot about, which is why I don't want to talk about it too much. Yeah. But it's something I came across while I was looking into cancer.
Yeah.
That like sun exposure mutations don't actually correlate with cancer.
Wow.
It was higher in less sun exposed groups.
Wow.
Okay, so we've talked about mutations not causing cancer. Now let's bring it to the solution. So I referenced the mitochondrial metabolic theory.
The solution to cancer?
The solution to cancer.
Wow.
This is what it is.
It's done? It's discovered?
If you have been diagnosed with cancer, this will give you a better outlook. If you don't have cancer, this will decrease your chances of getting it. It's not a drug you can take and you're good the next day. It's a lifestyle choice.
Let's hear what it is.
Sure. So when I found out mutations weren't exactly what causes cancer, I went back to first principles. I was like, okay, what do we actually know about cancer? And one of the primary things we know is that they all ferment for energy. So like very quick like biochemistry lesson on metabolism. When you consume food, you have a couple different pathways. I actually have a slide on this I can bring up. Right here. So when you consume food, let's say it's glucose, for example, that gets split into pyruvate, is what it's called. That's through glycolysis. That occurs outside the mitochondria.
Yeah.
The mitochondria are organelles, so like small compartments in your cell. Now, once you have pyruvate, it has one of two options. It can either go into the mitochondria and go through what's called the electron transport chain, and that's how you get ATP, which is energy, through oxidative phosphorylation. That's how me and you are getting it right now. When you're in anaerobic conditions, so when you have a lack of oxygen, or just when your output exceeds the amount of oxygen that you have, like when you're in the gym and you're lifting, you go to lactic acid fermentation. So the pyruvate, which is in the cell now, it's in the cytosol, it just skips and goes right to lactic acid fermentation. It never enters the mitochondria. So, okay, you know when you're lifting, right? First couple reps are okay. And like as you get more tired, you start feeling like this like it's a lactic acid buildup in your muscles. Like gym bros will know what that is. That's lactic acid fermentation. So as your output, your exertion exceeds the amount of oxygen that's available to you, you get put in an anaerobic state. And more of that energy goes towards lactic acid fermentation. This guy right here, Otto Warburg, in 1931. 1931, Otto Warburg, he got the Nobel Prize for figuring out that all cancers, or that mostly all cancers, ferment, even in the presence of oxygen.
Interesting.
So like this is a hallmark characteristic of cancers. This guy actually was Jewish during the Holocaust, and Hitler gave him, like he let him continue his research and actually gave him honorary status because of how important his research was.
That's powerful. Good. Wow.
So this is called the Warburg effect, which is the observation that most cancers use aerobic glycolysis and fermentation instead of oxidative respiration, even in the presence of oxygen.
Mm-hmm.
So this is like one thing we know for sure about cancer. So this is how I started.
So so starting here to simplify it, in layman's terms, what does it mean for the cancer to ferment?
Mm-hmm. So it means that it's choosing a inefficient or less efficient energy source over one that's better. The thing with oxidative phosphorylation, like I said before, is it has to occur in the mitochondria, right?
Okay.
The electron transport chain is in the mitochondria. So once you get that pyruvate in the cytoplasm, in the cytosol, if you can enter the mitochondria, that's better. You get like 36 ATP net, right? For like each molecule. In in fermentation, you get like 2. Plus you get a lactic acid byproduct, which is toxic. It builds up. That's why you have to stop when you're on bench press. So it's very bad. So it really doesn't make sense for the body to use lactic acid fermentation when it has mitochondria available. And that's the key word, when it has mitochondria available. Therefore, the fact that tumors rely on fermentation suggests the fact that the mitochondria are not available, that they're damaged,
Interesting.
that they're impaired. So that's where my theory, not my theory, this is a theory that's emerging in science, but that's where the theory I'm presenting comes from.
So I have a question. When you like came upon this and you're discovering this, and then you saw the fermentation, originally, did you know that other people have already discovered this? Because I found this personally, me, when I'm writing, fiction is obviously not as important as trying to find the cure for cancer.
Yeah.
But have you had that moment where you're researching something, and then you have a eureka moment, and then you figure out that this was already discovered hundreds of years ago?
So I'm gonna be honest, I did not have that eureka moment. When I first found all this from was a guy called Dr. Thomas Seyfried. He's at a Boston college. And this is actually, a lot of the papers I'm citing are his. So what I did was I watched his lectures, read all his papers, and then I expanded on his research by reading additional things. So I'm not the creation of this theory, the mitochondrial metabolic theory. I would say he probably is. He definitely is the lead researcher on it. Again, Thomas Seyfried. But I'm just presenting his research and trying to reach a different audience through it. And obviously I have a personal attachment to this story as well.
Yeah.
So again, going back to that textbook that I reread, in that textbook, it actually admits the fact that cancer cells use fermentation instead of oxidative phosphorylation. We can put that quote up. That's an excerpt from the textbook.
So that's a fact.
That's a fact. It's page 723. You can look it up. Find the textbook online. Otto Warburg got the Nobel Prize for that in 1931. Look, we know this is a fact. So they're fermenting. Now we have to look at, okay, what does that mean to ferment? We can pull up that chart again, but like to ferment, you need to have pyruvate. You need to have glucose. There's two fermentable fuels. One is glucose. The other one, which I won't really talk about, is glutamate or glutamine. It's a protein, but like it's not as obviously in our diet. It's not as prevalent and it's not as easy to cut out, right? Because if you cut out protein, you die. If you cut out glucose, you don't die, and that's because you can switch to fatty acid metabolism or ketone body metabolism.
A different source, yeah.
A different source. The interesting part, and I'll skip ahead to this here. So with the fermentation method, you might ask, okay, but why are they doing this? And again, like I said, it's from a dysfunctional mitochondrial system. So the mitochondria are damaged, right? I mean, this is all great, this theory, but like, what would you really need for me to prove to you or to convince you that the mitochondria are the problem? Like, what would you need to see?
I'd say cases of actual people who've had it, and that is a good question. How would you find out if it's the problem?
I'm theorizing that mitochondria are the problem. What would you need to see to believe that the mitochondria are the problem, that they're damaged?
I think you need to have a high percentage of people who have died from cancer, who beforehand you've seen that the mitochondria were damaged.
All right, let's go. All right, so the next thing I'm going to show you is that mitochondrial damage is well shown in tumor cells. So the way that mitochondria...
You set that up perfectly.
Thank you, man. You set me up too.
Yeah.
It's teamwork. The way that mitochondria work is they have these cristae, so they're like these folded structures inside mitochondria, and we can put up a picture as well. But that's how the electron transport chain works. So it passes between those two membranes. You build up a proton gradient on one side, and you pass it from one side to the other. That gradient is what fuels ATP synthesis. So it's very important to have these cristae. This study right here shows that normal mitochondria, they have elaborate cristae, but when they looked at like scans in high resolution pictures of mitochondria in cancer cells, you can see they're completely absent. It's like empty inside. And mitochondria cannot function, like you can't have the electron transport chain without a gradient, without a membrane.
So how is it empty?
So if you look at all this white space here, and like we'll put up a picture to compare. I don't have it in the presentation, but all that empty white space, it should be like little folds in there, like ripples.
Okay.
And it's through those ripples that you get the gradient and you get the ATP production at the end. There's no folds in this. So like you wouldn't be able to use the electron transport chain. These are damaged mitochondria. So the first thing is like you'd have these mitochondrial abnormalities, right? Then you have compromised energy production. You can't use oxidative phosphorylation. Then you'd have this retrograde signaling response. So the mitochondria would signal to the nucleus like, hey, we're not good anymore. We can't do this anymore. And the nucleus would go, okay, let's go to fermentation then. So that's how you get that Warburg effect shift. Again, like here's another study right here. They're just showing that like on the left is normal mitochondria. On the right is abnormal mitochondria. They're counting. So which one is positive that they're counting in both? So normal mitochondria on the left in the control, so healthy people, way more normal mitochondria. In the GBM, glioblastoma, way less. And obviously that's the inverse, right? It's like in the glioblastoma, we see abnormal mitochondria. And there's some pictures for that there. Okay, so the mitochondria are clearly implicated. But again, we're still like reaching for straws here. Like when you're a scientist, you really have to prove a theory, especially when it's as big as cancer, right? Okay, so we see the mitochondria damage. We're hypothesizing that, all right, due to this fact, they're switching to fermentation. This right here should basically, this should prove everyone wrong. That cancer is a metabolic disease and it's not a nucleic disease, meaning not a genomic disease. So these are the nuclear transfer experiments. That guy I was talking about, Dr. Thomas Seyfried, he didn't do any new research. In this paper he published, all he did was he looked through like 5 different articles that have already been published in a new light. So
Wow. So we might actually have all the source material to find the cure for cancer. We just need someone like you to like put it all together.
So I'm a bioinformatics scientist. This is exactly where I thrive. I don't like doing wet lab science. There's the NVIDIA CEO. I listened to him talk recently, and there was this one quote I wrote down. He was saying that the last 10 years have been about collecting data, and the next 10 years will be about using that data. All the answers are already there. And that's what I believe. So like when I do work, I'm not producing any new research. What I'm doing is I'm analyzing, reinterpreting, looking at things from a different lens. That's what Michael Safry did here. So
you don't have to. It's already there.
It's already there. You just got to look through it again. We've been collecting data for so long.
Wow.
So this is what he showed. This is his diagram from his paper. And this is proven by, I've read each of these 5 papers. You take a normal cell, you get normal cells. That's what you're doing right now. I was about to say me, but it's technically not what I'm doing. I had a little bit of tumor. Tumor cell. You start with a tumor cell, you get a tumor cell.
Yeah.
That's tumor growth, right? Here's the thing though, this is where the transfer part comes in. You take a normal cytoplasm. So cytoplasm is everything surrounding the nucleus, including the mitochondria. So normal mitochondria, you put in the tumor nucleus. So we have all those dirty mutations. We have all those cancer-driving mutations. This tumor was previously, or this nucleus was previously causing a tumor.
Wow.
Okay? You take that nucleus, you put it in a healthy cell. What do you think? Did we get tumor or not?
Tumor?
Nope, you don't get a tumor. If you take a damaged nucleus and you put it in a healthy cell, you don't get a tumor cell. So like right away you're thinking, okay, well it can't be the nucleus. Doesn't make sense, right? You take a tumor cell, you leave the nucleus in there. It's got all the mutations in there. Now you put in an abnormal cytoplasm. You put in those damaged mitochondria.
Then that's the problem.
You get a tumor cell. So right away, the issue is not the nucleus. It's not the genome. It's not the DNA mutations. It's something in the cytoplasm. What is it? It's the mitochondria, as I've shown you from all those damaged pictograms and also the metabolic evidence as well. So then you may ask, like, okay, but where do the mutations come from?
Yeah.
Right? Because like we obviously see them. They're there. When you have a misbehaving electron transport chain, what you get is you get these free radicals, they're called. So I'm going to pull up an image here. I'm focusing on this intermediate here. It's called Q, ubiquinone. Okay? So it's something along the electron transport chain. It accepts electrons, it donates electrons. What are you taking in university right now?
I'm doing honors finance administration, so business.
Okay, nice. High school, did you take science?
Yeah.
Do you remember redox reactions, reductions, oxidations?
No, can you explain to the viewers?
Yeah, absolutely. So when you reduce something in a chemical sense, it's gaining electrons. When you oxidize something, it's losing electrons. So along this electron transport chain, Q sits in the middle, and the electron is transported across the chain, and at a certain point, Q will be oxidized, so it will not have an electron. Then it becomes reduced, it gains one, and then the electron leaves and it's oxidized again. The thing is, in between that process, it's not 0 and 1. There's a half oxidized form, a half reduced intermediate called semiquinone.
Where it's both?
Where it's in between. So it has, let's say, like half a charge, a partial charge. Yeah. And that's highly reactive. It's unstable. There's an unpaired electron, right? So this is a quote here. The major source of mitochondrial free radical generation is Q semiquinone. Okay, so this is what causes free radicals. Again, from that textbook, it even says that free radicals are very dangerous in the electron transport chain and that this intermediate has to be avoided. Okay, so when you have a damaged mitochondria, you have an impaired ETC, electron transport chain, you get a lot of this semiquinone. It's a free radical. What do free radicals do? These free radicals damage cellular components. They damage DNA. So what I'm proposing and what Michael Safry is proposing and what I think is the answer is that the DNA damage is not the cause of cancer. It's a downstream effect of this impaired ETC where you get free radicals that then attack the DNA. And that's why it's like random. That's why when you say, oh, ROS is only in 30% of tumors, well, it's because ROS is not causing it. It just happened to be that ROS was the one that was damaged in this 30% and it wasn't in this 70%.
It's what was damaged.
It's just damaged. Like, it's combinatorial, right? And it's maybe not the mutations. It's that this damage is random. So you get a random set. So the source of what, sorry?
The source of cancer?
Source of cancer would be the impaired mitochondria. You get the unbridled growth. So
how do you fix that?
Well, I'll take you back because you asked a really good question, which was like, how does this cause cancer? So I talked about mitochondria being a separate component in the cell. There's this theory called the endosymbiotic theory, which is that at a certain point, mitochondria were their own organism. And we were our own single-celled organism. This is before eukaryotes, before we were like mammals, like us. This is like when we were all cells. And at a certain point, we engulfed the mitochondria, and now they're a part of our system, but before we were separate. And that's evidenced by the fact that they have a double membrane. So like all the other organelles in our body have a single membrane, which makes sense because they came to be from within the cell. If something came from outside, it would have its own inner membrane plus an outer membrane from being a single-celled organism. So mitochondria come from outside the cell. Before we engulf these mitochondria, this is a quote here, proliferation is the default state of metazoan cells, i.e. the state under which cells are found when they are freed from any active control. So mitochondria, still in the quote, they maintain the differentiated state in the quiescence, so the peacefulness, the calm. They calm the unbridled differentiation, the unbridled growth. Before, in this metazoan era, you would just have growth. Like that was the meta. It's just like you grow until you die. It's like bacteria. It's just gonna grow until you clean it. That's what it was. Now we stop growing and we have these tumor suppressor genes and we have these things that control our growth. When you switch off oxidative phosphorylation,
is that, now this is kind of like a different topic, but is that some sort of evolution that's happening there?
With what?
Because you said originally they would just grow to die, but now our bodies are naturally treating it better.
I mean, yeah, absolutely. Like we're not the same as metazoan cells. Like that's the process of evolution. Along that evolutionary timescale, it's theorized that we engulfed mitochondria and plants engulfed chloroplasts for that matter. It's the same kind of thing. And that now that we have mitochondria, we have access to, remember, 32 ATP or 36, whatever it is. It's a lot. Now we can grow a lot bigger. So now we need to control that growth.
I see.
Right? So we stop growing at a certain age and we don't just keep differentiating and growing. So mitochondrial retrograde signaling is this pathway response. When the mitochondria says we're damaged, switches the cell back to that default metazoan state. That's where you get the unbridled growth. So long answer to your question, but that's what causes cancer.
So if you could simplify that to the audience in like a sentence or two, just simplify and summarize the cause for cancer from that.
When you chronically stress your mitochondria through overeating, glucose, insulin spikes, and not being active enough, your mitochondria send a signal to the nucleus to switch from oxidative phosphorylation to fermentation. And that fermentation method is a state of uncontrolled cell growth.
So basically one of the root causes, when you said it's a combination between different things. One of the pieces of the puzzle is an unhealthy lifestyle.
Oh, for sure. I mean, it's like all diseases, right? And like, I mean, I got excited when I heard this. Obviously, it's a dark thing, but like, I was like, all right, well, if it's in my control, there must be something I can do about it,
exactly.
Right? So we talked about the fatty acid metabolism. I learned that through diet, you can control tumor growth. And we'll look into some evidence for this now. We looked at the mitochondrial damage. We looked at the nuclear transfer experiments, free radical. Okay, so the metabolism of ketones as an alternative to glucose. Mm-hmm. So we'll go back to this again. You start with pyruvate, has to go inside the mitochondria, etc. Fatty acids can bypass pyruvate. They don't go through glycolysis. They can enter as acetyl-CoA directly into the mitochondria. So you can still have the electron transport chain, but without any glucose. That's why I was saying that you can cut carbs to zero. I talked to my radiologist about 4 months ago, And I asked him, like, I didn't berate him with this stuff, but I was just kind of inquisitive. I was like, all right, what sort of diet should I be on for this cancer? And I've asked this to all my doctors. And they give you the default answer, which is balanced diet, Canada Healthy Food Guide, 50% carbs. I think they decreased it to 25% now, but whatever, right? It's like, have some carbs. Yeah. And legitimately, this is the answer he gave me. I go, why do you need to have carbs? He goes, well, I'm Asian. I like rice. He goes, you're Indian.
That's the answer. It's just he likes rice.
You're Indian.
Is it still green? Yeah.
You're Indian. You like roti. He's like, it's a culture thing. And at this point, my dad knows all this research. He was there with me. Science. He gets mad, right? And he's like, okay, but like, do you actually need carbs? Can you just cut it to zero? And he's like, yeah, like, I guess you can. And like, I've looked at the research, all of the energy demands.
So how is that like an official stat? If it's like, I guess you can cut it out.
I mean, I'm not trying here to talk about this, but it's the food industry, right? I mean, carbs are cheap. They're also addictive, like sugar, fructose, high fructose corn syrup. Any of those monosaccharides are very addictive to you. And it also fuels the cancer industry, as we know. So you have a lot of cancer drugs. You have radiation machines. You have MRI machines. You have doctors being paid on salaries. Like, there's a lot of money in this, right?
We're getting into controversial territory.
And that's why I didn't want to talk about that. I'm not as educated on that topic.
That could be possible. That's not, for the sake of sakes. That's not our opinion, but it's a great something to think about.
How do you become a radiologist or a doctor and not understand this? Unless it's being purposefully, I don't think they're bad people, doctors, at least not by choice. They're not purposely leading people down a bad path. I think they're just not taught these things. Like I showed you, that textbook and the cancer website say cancer's genetic. They don't say it's metabolic. We've known this since.
So until like this video and that article, it wasn't really that widespread, this information.
I mean, I'm just trying to get it to more people because, like I said, I've known people who have cancers. I know people now who have tumors. I have a tumor, and I just wish someone had told me this back then.
Yeah.
But I did the research because this is what I do. I'm a biologist. I'm a scientist. So I did the research, and now I'd like to share it with your audience. So yeah, fatty acids, they bypass, go straight into the mitochondria, etc. You get the energy. Now knowing this, let's look back at the standard of care. So like what we currently do to people who have cancer. And it's not good, right? Like I'll pull this up here. This is a quote from a paper. He says that no major advances have been made in improving overall survival for glioblastoma in almost 100 years. So he looked at stats from 100 years ago. This is published in 2019. So 100 years prior to that, and then 2019. And the survival rate is about the same. This graph here that I'm showing you is when we have a GBM patient, glioblastoma, with radiotherapy. And then we got this new cancer drug, billions of dollars. It's called temozolomide. Let's give that to them. And like the survival curve is almost exactly the same.
So how is the survival percentage so high at the beginning?
Okay, so what this is this is the time along the x-axis. So this is in years. So this would be 6 years at the end. This is 1 year here. And this is the amount of people that are survived or that are alive at that point. So at time 0, everyone's alive. As you get further in the
age,
time past initial diagnosis. So as the tumor gets bigger, more people drop off, right? They die from it. So the standard of care is very bad. So now knowing the mitochondrial dysfunction theory, let's look at why the current standard of care is not working. So first, what would an ideal therapy do?
Therapy in what sense? For like your emotions?
You got a disease. Oh, let's say a physical disease, not mental. Yeah. What would the ideal therapy do?
Solve it.
Right, it would solve it without, and the caveat is what you would expect is that it wouldn't hurt your normal, like the healthy parts of yourself. Yeah. So the golden rule is we want something that kills the tumor cells while also keeps the healthy cells healthy. Radiation does not do that. Radiation is promiscuous. It does not care. It kills everything. So I went through radiation. When you go through radiation, you get put under the beam and it just kills everything. Now they do try to target, like, let's hit your tumor, but like there's things in the way, right? I have symptoms right now that are not from the surgery and not from the tumor. They're from radiation. You also get radiation-induced necrosis, cell death. You get scarring. That's very bad inside your brain. So for these reasons, Winter et al. 2019, radiation-induced necrosis is now recognized as a serious issue for brain cancer patients. Seyfried, that same guy, says that surgical resection and radiotherapy damages the brain microenvironment, increases glucose. As a response, what does glucose do?
So what does that mean? Sorry.
So whenever you damage something, the response is that you have glucose released.
Yeah.
It just gets it's not controlled anymore when it's damaged. So if you go in with a knife or a blade, you're damaging cells.
Yeah.
If you radiate them, you're damaging cells.
Yeah.
When you damage cells, you release glucose. And then where does the glucose go?
I see.
Straight to the tumor. So surgical...
So what does the glucose do to the tumor?
It goes into that, it gets fermented and it helps them grow.
So basically, we need to stop the glucose from going there.
Oh, you got it. We need to stop the glucose. And that's why I'm proposing metabolic therapy, which is through being in a keto diet, so abstaining from glucose. And instead of burning glucose for energy, you're burning fatty acids for energy. And fatty acids cannot be fermented. So what you're doing now is we have that golden rule. We're selectively starving the tumor cells, where we're keeping the healthy cells healthy.
And this is much safer than radiation then, right?
Yeah, because it's actually better for you. I'm not going to go into that, but like there's a higher inherent heat of combustion in the same amount of the dihydroxybutyrate than, which is like the fatty acid byproduct, than glucose. So you're actually getting more energy. I saw a paper recently which was saying that like for astronauts or high endurance athletes, it's better to be on a keto diet because you get more energy.
So if it's better for them, it should be better for us then. Doesn't matter your profession.
It's better for anyone. And what I'm saying is that this is the golden therapy here. The problem is that it's free. So again, going back to that controversy,
where's the industry there?
Where's the money? Yeah. How do we get paid? Right? So what I'm showing you here in this diagram,
gyms.
Sorry?
Gyms, that's how you get paid. Make a gym.
Pretty much, make a gym, make a restaurant, maybe a keto restaurant. I would love that personally if anyone wants to make that.
Yeah, contact him, if you want to.
So this diagram is from that guy Seyfried. It's a 2019 article. What we're showing up here in the red is radiation. And what's happening is we're getting glucose, which is released from that damage, fueling the tumor. We're getting glutamate, which is what I talked about before. It's very tightly regulated in the brain. Unless you start radiating it, that fuels the tumor. The second thing up here is showing that dexamethasone induces hyperglycemia. Dexamethasone is a steroid. So I'll flip to the next slide here.
Wait, so before we get into that, I was wondering, what is the difference between trying to treat your cancer with a keto diet and just fasting and not eating anything?
Yeah, so honestly, I'm not an expert on how to get into the keto diet. Your body switches to ketosis in the absence of carbs. So when we store fat, right, what that is your body going, all right, well, right now we got glucose, but on a rainy day, we may need this. So let's just keep it here for now. When you fast, all fasting is doing is it's switching to ketosis. So when you fast, you're doing a keto diet. What I'm saying is that when you fast for 72 hours, you're in ketosis for 72 hours. If you do a keto diet, which is like selectively choosing what you eat, you can be in ketosis for as long as you want.
Without having to not eat for, wow.
Well, you would eat. You just only eat fats and protein. That's what I'm saying.
And it's the same benefits as normal fasting.
Yeah, like not for weight loss, but for cancer, yes.
So everyone should be doing that then.
It's the optimal way to live. It's a superior way to live. Yes, it's just hard to do. Like I've been keto for a year now, or very low carb.
Is it because of temptations?
No, it's just hard to find foods that don't have sugar. So this is actually a perfect segue.
That's another industry right there.
When I got radiation, the first night, you get it every day. They give you like a cumulative doses every day. The first night, I was in the worst pain. Yeah. Like, I've been kicked in the leg. I've had brain surgery. This hurt, okay? And I couldn't sleep all night. I had a little bit of tears, and it was very painful for me. And the next morning, I called my radiologist, and I told him my symptoms. I go, I don't know if I can do this. And he said, no problem. This is normal. This is inflammation. It's edema. It's swelling. What we're going to do is give you a steroid, dexamethasone. and it's going to reduce that swelling. Dexamethasone does reduce that swelling. What I'm showing you is that it also induces hyperglycemia. It increases the amount of free glucose in your bloodstream. So it's not good for you. So yes, it helps. It's not that golden therapy. It's hurting you, ain't helping you. KMT, keto metabolic therapy, right here, this bottom quote, also decreases the need for high dexamethasone. So I'll tell you a story. That first day, I was in all that pain. I was already on, like, at this point, it was keto. I was having like 0 carbs for like 3-4 weeks. And again, I hit a critical point. It was like, all right, I've been offered this drug. I already have read the research. I know what's bad for me. What am I going to do? Like, stick or twist, you know? And again, it was about putting faith in myself and in the universe and in God. And I was like, all right, I refuse to be a victim to this. I'm not taking that drug. There must be something I can do. And I have an app on my phone. I track all my food. At that point, I was only eating meats, chicken and beef, unbreaded. That's all I was eating. The thing was, I was having a hot sauce with everything. I was eating meat with hot sauce. So when I went through my app, I'm like, 0 carbs. What else? Water, sparkling water, that's 0. Hot sauce, okay, I'll check the hot sauce. It was a mango habanero hot sauce. Per teaspoon, 15 grams of sugar. So I thought I was having no carbs. I was eating this hot sauce with almost every meal and like a lot of it. I cut out that hot sauce. I never took dexamethasone. I didn't have any problems. That was the first day of radiation. I went for, I forgot how many days now. It was at least like 30.
So you just have to be much more conscious of what you're eating and putting into your body.
I mean, yeah, like you're putting stuff into your body. It's going to have an effect on your health, right? So
people, and like, just like you, like, who knows if you didn't have this yourself, people go eating hot sauce and all this sort of, junk food their entire life, right?
Yeah.
And they don't realize that for you didn't have to take that, what was Dex, just because you call it hot sauce.
Yeah, like I was very receptive to my symptoms because I was getting radiated. Mm-hmm. So like my edema, my swelling was directly, it was painful at that time, right? But like, if you have a little bit of swelling or you have like a chronic problem, you're not going to feel it in the moment. You're going to feel it 40 years down the line when you're diagnosed with a tumor or with cancer. That's when you'll feel it. For me, I was feeling it like day to day. So I was able to be very cognizant and very I could put a lot of attention on myself. Yeah.
So now that you have this this theory that, correct me if I'm wrong, but that a keto diet could be a cure for cancer, how do you go and prove this?
Yeah, absolutely. So this is the case study. This guy, Pablo Kelly, huge inspiration to me. He was diagnosed with one of those glioblastomas. Okay, so he was a 32-year-old man presented to the hospital. He was diagnosed with a brain tumor in 2014 when he was 24. He was given only 6 to 9 months to live. Better than me, but 6 to 9 months.
Not 48 hours.
6 to 9 months to live without treatment, and he was given 12 to 15 months with conventional treatments. He refused the standard of care, and he instead, like a cowboy, decided to do this keto diet. So I have his exact regimen here. And first, before I say that, he lived over 10 years. So given a 6 to 8 month prognosis, you're going to die in 6 to 8 months if you don't do anything. He said, fuck you. And he lived 10 years.
Wait. So that doesn't completely solve the problem then. It just gives you more time.
Well, no, because he didn't actually die of the tumor. What he died from was a surgical complication.
That's different.
So the tumor didn't even kill him. He was doing so well that the doctors were like, all right, you have a small bit of tumor here. You're doing so good. Let's go back in and just take it out. So they went back in, took it out. And there's a picture of him after the radiation with like thumbs up smiling. And like right after that, he got, I think it was a hemorrhage and died. So it was a surgical complication, not the actual tumor. But like still, bro, you're told like 6 to 9 months to live and you live 10 years. He had kids during that time. Like he had a family. He's the original. He's the OG gangster.
He's the OG, but so do the doctors not know that, or they don't want to know that, or is it whoever's teaching the doctors don't want them to know that?
So, like, again, the textbooks don't tell you this, and you have to think about who's writing the textbooks, who's choosing what gets taught in university. Universities are businesses. There are donations, essentially lobbying. Who has the money to be able to lobby for what gets taught? It's going to be the big pharma and the big food industry companies, and they don't really want you knowing this. No.
Very interesting.
So you asked me a very good question, which is how do you actually get in ketosis? What Pablo did was he ate a low carbohydrate ketogenic diet. He journaled everything, and a scientist actually went through and verified his claims and published a paper on this. So that's linked there. He kept his glucose ketone index, which is like a measure of how much glucose is in your bloodstream versus ketones, under 2.0. So that's short answer to your question. That's what I would do is GKI under 2. And
which is what?
So it's the ratio of how much glucose you have in your bloodstream versus ketone bodies in your bloodstream. I would keep that under 2. You can buy a monitor. I don't know how much. I think it's like under $200, but you buy a monitor. It's like an insulin monitor. You just want to watch that for being under 2. That's how you know you're in ketosis. So what he ate was right here. He actually wrote this down. Eggs, bacon, fried in ghee or butter. So clarified butter is ghee. And then he would have bacon, steak, lamb chops, beef patties, liver, all fried. 2 meals a day. And that's exactly what he ate. So like this is a case study. I know it is, but like 6 to 9 months, he lived 10 years doing that.
Wow.
So that's what I would do if you were in that state. And this has been actually shown in studies with mice.
So no vegetables.
You can eat minimal vegetables. The thing is that vegetables do have carbs. A lot of times it's fiber, so it's all right. But you need a little bit of those micronutrients, the vitamins in vegetables. I would say fruit, you don't need, cut it out. Like
you don't need fruit.
So like, okay, this is unclaimed now. This is my own personal theory.
There still needs to be research done, but yeah, let's go ahead. Yeah.
The body makes no differentiation between simple sugars in an apple and simple sugars in a fruit roll-up. It's the same. When it hits your body, it's glucose. Glucose is glucose. There's no such thing as good sugars and bad sugars. Sometimes the good sugars are wrapped around in things like an apple has fiber. So when you eat that fiber, it creates a coating in your stomach. It slows the uptake of glucose, so you don't get as big of an insulin spike. And there's also micronutrients. There's vitamins in there, so it's okay. But like people who say to me, "Well, shouldn't you eat fruits for the vitamins?" Wine has antioxidants. Should you get drunk every day on wine because it has antioxidants? It's like, no, just get the antioxidants from a healthier source. Get the vitamins from a healthier source.
So what makes the fruits unhealthy is the sugar, is it your claim?
So if you search up a picture of a banana, for example, from 500 years ago, you would not recognize it. It does not look like a banana. What we have now are genetically modified organisms that we've either genetically modified or that we've modified through artificial selection.
So it's not like the natural real fruit.
No, like fruit now is essentially candy. It's just full of sugar. So to be in a keto diet, what I currently eat, and I can pull up what I ate today, I did have a little bit of carbs in the morning. I ate protein yogurt, which had 6 grams of carbs, but I worked out right after. So there's a hack for you is that when you eat carbs, and if you don't want to change your diet, you can change your lifestyle. So if you go for a walk or you work out right after you eat, you're going to burn those carbs. Your muscle cells will burn those.
So sometimes the solution is much more simple than we make it out to be.
Sometimes you gotta hit the push-ups, bro. You don't want to die, hit the push-ups.
Yeah.
Or again, you start with carbs.
If you're watching this right now, just hit a few, Could
please.
Save your life.
Yeah, he's gonna do 1 push-up for every like this video gets.
Okay, sure.
But what I want to show you is this research here. So they gave mice, they separated them into 2 groups, okay? You get an ad libitum group, which means they eat as much as they want. You get a second group.
Testing on mice, yeah.
Bro, I do this shit too, it's fine.
You do?
Well, in my company, we test on animals. You have to.
Oh.
You remain ethical about it. You only do the minimum amount.
No, I'm just saying it's interesting how that's the first thing we start testing on. It's just interesting to me how it starts with mice.
I mean, for the case of this, the biology is very conserved, right? So we have the same metabolic systems. They have the same citric acid cycle. They have the same ETC fermentation. It's all the same. So it's analogous. So we can study in them and then assume that the same thing happens in us. So what they did was 2 groups, one ate as much as they wanted of a high carb diet. The other group ate only keto diet, so fats and proteins, and they ate only 70% of what the left group ate. So it's a 30% caloric restriction as well as a change in the amount of the type of food. So it's keto, 30% restriction. Here's the size of the tumor, so the dry weight of the tumor in milligrams. So they implanted them with an astrocytoma brain tumor, separated them into 2 groups. You can see in the ad libitum group, they ate as much as they wanted. The size of the tumor is way bigger than in the group that was on the keto diet. This is a picture of the actual cells. I'll blow this up. So you can see the tumor mass is here. Here's the healthy mass of the brain. And in the group that was eating as much as they wanted, you can see like the tumor is infiltrating into the healthy brain. That's tumor growth. In the group that was on the keto diet, the tumor is not infiltrating as much. It's dying.
Yeah. I just want to say, like, a personal thing here too. I also have a tumor as well in my spleen. So what happens is, a few years ago when I was in grade 6, I almost died of salmonella. It wasn't, 48 hours to live, but I was given like a due date, to my life. And yeah, essentially that's what happened is the cells, I'm not as scientific, so I don't know exactly what it was, but the spleen is what keeps you, like, avoids you from sickness and is your natural, like, military defense of your body.
Okay.
And basically what happened is they went onto the tumor, or they went onto the spleen, the bad cells, and they duplicated it and cloned into a mini, like, malignant spleen, so to say. And then that started attacking my body, and then just like you, was in the hospital, and we never figured out what it was. So, and then eventually when I got cured,
you're good now?
I'm good now. Yeah. They were like pushing surgery, and then my parents said, no, we're not doing surgery.
Yeah.
They prayed. I think faith has a big deal. It's really interesting how it's like a combination between faith and science, but I digress. But basically, yeah, it's similar to me. It was infiltrating and then copied, and then basically I was essentially fixed through medication.
Right.
And then now I still have that there, and now it's just benign, sort of just like a mini spleen that does nothing. So
I'm sorry to hear that, bro.
Yeah,
I'm glad you're doing well now.
But there's nothing compared to cancer. But maybe, who knows? There's some correlation somehow that could, maybe a missing component of the cancer research could be found there. You never know.
Yeah, so the word you were looking for is metastasis. So when a tumor grows, proliferates, and it invades into a non-cancerous region, it spreads, it's metastasizing. And that's what characterizes the highest grade tumor. So for me, I have to get my spine checked to make sure that in my CSF, my cerebrospinal fluid, the tumors aren't being being shuttled through there and then starting a new spot, a new tumor in other places in my body. So like same thing as you as well, right? Is that these tumors do spread. But what I'm showing you is that the keto diet in mice stops the spread. And this is a blown up version of that same image. There's something called mitosis, which is like cell division. You can see on the left here, when the mice are eating as much as they want, that dense region in the middle, that's the DNA, is like separated, like this one here. You see it's like separate. Yeah. So it's starting to divide into 2 cells. Yeah. At the same time frame, they take the same picture in the keto mice, and you can see there's that calm, dense ball. It's not dividing. So that's why in this image, we see that stuff is spreading here and it's not here. That's because they're dividing here and they're not here. That's my theory, and the theory I wanted to present to people. If you've been diagnosed with a tumor, it's not out of your hands. Have faith, but also know that you can take steps to improve your health, which is being on a keto diet.
Before you get into that, was there other research you'd like to show?
Like not that's relevant, that would improve my point. If you want to see like more studies, I have a lot of stuff in here, like dot shots that just further prove my point. That'll be in the Medium article, but that's essentially the very long Cold's notes of what it all is.
Mm-hmm. Yes, that's very interesting how you could like distill it in like such a simple format. And the way I like to end every podcast, I always ask this one question to the guest. And before we wrap this up, guys, if you enjoyed this video, make sure to comment down like what you liked about this. We should definitely continue this another time. I think it was a great episode. It's probably going to be one of the highest performing ones if I just like look at it from that faith perspective.
In one like for every push-up, right? So like the video.
One push up for every like.
Sure.
Yeah. So yeah, make sure to subscribe, by the way, because trying to hit 1,000 by the end of the summer, and when we hit 1,000, my official Thomas Botea publishing hats will be released to the public, and my author website, and we're gonna keep on bringing great guests like Ishaan right here and speaking about stuff they're passionate about and science and faith and writing, because he's also a creator himself. Before we get into the key question that I ask at the end of any podcast, I'll give you now just a moment with the audience if there's anything else you'd like to say about your research or any other like concluding thoughts before we wrap up.
Never give up.
That's all? And never give up. All right, so in line with what you just said, it's actually, I think this will be your strong suit. The question I ask at the end of each podcast episode when I have a guest is, what is your biggest philosophical take that you'd want the entire world to hear right now, and a select audience of the world is watching this right now, that they need to know, but the catch is, when you look at them and tell them this, you're only allowed to say one word and one word only.
Responsibility.
That's responsibility. Now that we know that, in their mind, they have it. Now it's going to be easy to explain. So just explain to them why, out of all the words that there are in the English alphabet, you chose to say responsibility.
So a key component of my mindset is this idea of ultimate responsibility. It comes from, I really distilled it when I was writing a speech I gave about 3-4 years back. And that speech is on my Medium website as well. And the core idea of that speech is that everything is your fault. So good thing happen, it's your fault. A bad thing happens, it's your fault. Essentially just not being a victim to your circumstance. So whatever happens to you, you do still have personal autonomy, and you can do something to make it better. So no matter what happens to you, you have to take responsibility for it and ask yourself, all right, I'm in a bad position, but what's the best possible move I can make to get in a better position?
Just like chess or anything.
Just like anything, man. Like anything in life. Like when you get punched in the face, or when you're really down on something, it doesn't help to just sit there and be like, all right, let's see if it gets better.
Yeah, no, you have to say, you know what, who cares? These are the cards I'm dealt. What's the best move to do now?
Best move on the chessboard, yeah.
Yeah, this is actually, I actually saw a quote recently. I'm not sure if you know the businessman. He's popular on YouTube, Alex Hormozy.
Yeah.
But he likes to do little like motivational quotes, business related. And one of the ones he said was really in line with what you said about responsibility. We experience pain and suffering regardless of what you do. So all you have to do is just choose which suffering you want to have. If you're not working out, the suffering is going to be from the obvious side effects of honestly, not for like cancer related as well, not just health style. Or if you do choose to work out, tough luck. There's still going to be suffering and pain regardless of that. So shout out to him. He probably doesn't need it. He's much bigger than I am. But you just have to choose the suffering that you want, because it's unavoidable, and that comes with responsibility. Yeah.
All right, Thomas.
Yeah, that's Ishaan. For everyone, thank you so much for coming on. I truly had a great time in this podcast. And let me know what you guys think down below. Make sure to like the video if you liked it, disliked if you dislike it. As he said, I'll do one like for every push-up. Or one push-up for every like. It's probably only gonna get like 2 likes, They average around 20 views.
This one will pop off, don't worry.
Yeah, it'll pop off, Yeah, let me know what you guys want, and down below, if you're curious, and you should go check him out right now, I'll put his Medium link in the description. You can read his articles that he's written, and as well, you said you have a YouTube, but do you have videos on that?
Yeah, I'll put my YouTube as well. The best way that you can get content from me is through my Instagram. I just put everything on there. So business endeavors, school, if you want any research to work on, any other endeavors, all through the Instagram. So I'm the same person. So I'll link everything from there. I have a couple interesting LinkedIn articles. I have some YouTube videos of some apps I made, which are really interesting. And again, the medium, it all comes from my Instagram. So we'll put that down below.
Yeah, so make sure to go check him out. Make sure to subscribe. I'd be happy to have you back on. So make sure to follow him on Medium, because I assume it's this Monday where you're gonna post this this research as well.
Yeah.
So lots of concluding remarks. Thank you so much for coming on, bro. It's been an honor.